Here's our ever-ready battery, the 9 lives radio battery with the cat. I went ahead and kind of surgically opened up the bottom of it. It doesn't look anything worse for wear from the top, but I did open it from the bottom so we can see what's inside. And there's lots of goodies inside. And I think I can slide it up. Let's see here. Push on these. These terminals stick out. They're threaded terminals. I can push on those and slide it out. There it goes. There we go. Oh, there's a little spacer block in here. A little piece of press board. And a couple of spacers. A spacer for the side made out of cardboard, and a spacer for the top made out of double ply cardboard. A little bit of battery goo on that. But look at this thing. Wow. I zoomed in all the way? Almost. Yeah. All of these cool cells in here. I have no idea how this is constructed. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So if they're a volt and a half, 15 plus 2.5, that's not right. So it's 22. Oh, I can't do math in my head anymore. You know, I have a degree in mathematics, but I can't do algebra. 22.5. How many did I say there was? 15 of them? 1.5 volts. Oh, duh. I just can't, like I said, I just can't do math in my head. So, yeah, so 15 cells. So I downloaded the electrical service manual for this thing and looked to see where the battery is used. The way that it's used in the circuit is that there's AC coming in, goes through the transformer. The transformer gets rectified. It gets rectified with one diode and one capacitor. And that's how it gets rectified into, guess, 22 volts. So the switch in the back, here, you flip it up, it says battery. Flip it down, it says line. All that does is either connects the battery at that point or the rectified voltage at that point. So that's how it does its battery thing. And then it generates plus and minus 6.7 volts. Kind of a weird number, but plus and minus 6.7 volts. I've seen 6.7 volts in other HP equipment, so it must have been a favorite voltage of theirs. If it is 6.7 volts, and there is some circuitry to regulate those voltages and stuff. I don't know how large the dropout voltage is on those regulators, but it may be that 2 9-volt batteries would work just fine in this thing. So they're not going to have the amp hours of this thing. This thing has like 2 amp hours. I don't remember how much 9-volt batteries have in them. I don't remember offhand, but they're like AAA cells. They're like really tiny. But I can imagine 4 9-volt batteries, 2 on one side and 2 on the other side for extra current, and that probably would power this thing up for some time. So I think that's pretty cool. The other thing I found out when I was looking at the schematic for this thing is it is a FET input device, and it guarantees input impedance of 10 megohms across all range settings. 10 megohms on the AC and 10 megohms on the DC. So that's quite good. So I think the next thing to do is to put this thing back together and try it out. So before I decided that before I calibrate it, I'll go ahead and replace all the capacitors, since this thing is, 35 years? I don't know, 40 years old? 40 years old, maybe. And there's not too many capacitors in here. Of course, this is back when they wrote real service manuals. They have all the schematics, and they have the the PC boards and all the part locations and everything. So I've marked where all of the electrolytics are. And of course in the back there's parts lists for all the things, so you can check off on all the parts lists and everything. So this is what I needed. 200 microfarad, 150, 100, 50, 35, and 10s, and of various voltages. So I've ordered those all from Mauser, and so I have the top and the bottom off. I don't think you've seen the bottom yet. Let's see here, zoom in. The bottom's real pretty. There's all of the switches down here. There's the boards come out. They're all socketed or pins. This will be the only tough capacitor to get to. This is on the power supply, but it's on a little standoff here. It'll be easy to get to. I found one interesting thing kind of poking around in this thing, which was over here. Let's see, where was it? Oh, here. So I think I mentioned this before. There's a 3 volt 100 kilocycle adjustment here, but I never got to see it because I didn't take the bottom off. So if you flip it under there, you see there's a variable capacitor that you're tweaking for the oscillator, and it's in a can here. So this section down here is the oscillator, and the oscillator must be used. I don't know what the oscillator is used for. Maybe the oscillator is used for the ohms. Maybe it sends out an actual AC signal, not a DC signal. So that'd be interesting. And here's the power supply. Like I said, there's a tiny little transformer. So this thing doesn't take much current, I guess. Tiny little transformer. I'm not sure how much this would have lasted if you used it all the time. And here's that switch in the back for enable the battery or disable the battery. Yeah, looks pretty nice. Ton of adjustments here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 adjustments. And there's quite a lengthy procedure on calibrating this thing, so that will be fun. Well, while I'm waiting for the capacitors to come in the mail, let's go ahead and test this battery out. Not the battery out, but the battery function. Obviously this battery's dead, so let's take off the little screw caps here. All right, so supposedly we have a 22 volt battery across here, and so let's go ahead and hook up a power supply to that. So I want to get a accurate measurement, so I'm going to use my 2400. So I'm going to say I want to source volts. I'm going to edit the compliance to 0225. So 22.5 volts, and compliance of current, let's make it, I'll say 50 milliamps. 50. All right, so we have sourcing vSource 22.5 and compliance of 50 milliamps. If I hit this button, it turns it on. So let's go ahead and do that. No harm there. So we're measuring the current. So we could measure the voltage by hitting this button, 22.5. Measure the current, it's nothing. So let's go ahead and hook up the minus lead and the plus lead, and we will turn the unit on. It's in battery mode now. Now on the front panel, I'm going to switch it to DC volts. Oh, there we go. So we're measuring 3.1 milliamps. So 3.1 milliamps for DC volts, and it should be irregardless of range. I'm going to change the ranges. Yeah, it's always 3.1. And if I hit AC volts are around 4 milliamps to run the meter. And then ohms, 4, 3, 12. So on the lowest, on the 10 ohm scale, we are going to draw 12.5 milliamps. But otherwise, it's always around 3 or 4. So the whole thing operates at 3 or 4 milliamps all the time. So what does that mean? Well, I did read the manual about the battery, and it says the minimum battery voltage when it doesn't work any longer is 15.5 volts. So anywhere from 22.5 to 15.5 volts, then it stops working. So we can use two 9-volt batteries and get us 18 volts, and those batteries can droop down to 15.5 volts. So, and I took a look at the data sheets. 9-volt batteries are about 500 milliamp hours. So if this thing drew 5 milliamps, that's 100 hours of operation. And so it's going to be a little bit better than that. It's 3 or 4 milliamps, plus we're going to allow a little bit of droop. So I'm thinking maybe 150 hours operation time for this thing on two 9-volt batteries. So that's pretty good, as long as you turn it off. So you're going to say, well, you know, why have it battery powered? Well, a lot of times it's really nice to have a completely floating supply, so it's battery referenced. That's the nice thing about some meters. These days, almost all meters are floating grounds, but back in the day, you had to worry about actually the common ground. In this particular meter, even in AC mode, the ground floats. So that's a good thing too. Well, I've taken all the capacitors out. I think there's 10 of them. And there's 2 boards, so remove the 2 boards. And they're just on these little connectors, single pin connectors. Everything's gold on gold. It's very, very HP-ish. And these were all Sprague capacitors. And I measured them all for ESR, and only one was a suspect. The 10 microfarad capacitor. There's 35s and 50s and 100s and 150 and stuff. Everything else looked pretty good. I'm impressed. Sprague does a good job. But I mean, I had it open. I'm going to calibrate it. I feel much better putting new capacitors in it. It is fairly old. I still can't quite get a really good date on this thing. I think it's a late 70s, early 80s. But I'm still not exactly sure. Nothing really had a date code that stood out. I went ahead and created a faux battery, a fake battery. It's still in the plastic thing, and it has the screw terminals on top and everything. So it looks official. It looks like there's a real battery in there. And there's 2 9-volt batteries in here. So this is an 18-volt battery down on a 22.5 volt battery, but it's an 18-volt battery. Should last, you know, some good amount of time. It looks the part. It looks really good. And those batteries can droop down to 15 volts, and then it'll be time to change them. But it should last quite a while. All right, I got capacitors back from Mauser. So let's take a look here. Those look nice. It's probably the 150. Oh, that's 50. Oh, okay. Well, let's figure out what we need here. We need a 10 100, and that's this one here. Yeah, that's 900s. Good. Yeah, that's good. 30s, 35s. Okay. These are right. Right, which goes here, and there goes way down. That was there. Good. So, anyway, 200 volts. Okay. All right, there we go. Okay. All right, the boards are back in. And I believe this is the DC board. And I believe this is the AC board. And now we get to try to calibrate it. Okay, let's see here. So the first thing we'll do is we'll check out the, we're in the off position, we'll go to the battery position, and it comes up. So we're reading the internal voltage we have AC applied right now. So we're looking at the 0 to 3 scale. So we're looking at about 24 some odd, 24.4 something volts, which is great. And then if we flip the switch in the back, and now we connect it to the battery, when we flip the switch, now we're looking at the battery. So the battery is measuring somewhere around 19.6 volts, something like that. So the battery's in good shape, and the power supply is in good shape. And so, what does it say? Short the volts and COM terminals. Volts and COM terminals, short these together. I used to have a shorting block somewhere. Yeah, I do. I have a shorting block for calibrating other meters. So we will use that. So short these together. Set the function to AC, to DC plus or DC minus. So here's DC plus. Set the DC 0 for 0 deflection. Okay, that's this. So we're putting it right on 0. And then it says remove the shorting. If the meter deflects, oh, it doesn't. Oh, nice. If the meter deflects, adjust, short them, and recheck the 0. So it looks like our 0 is great. All right, let's do it on minus. And our minus is also looking good. All right. Let's see here. Set the range to 0.1. Okay. So we are seeing a little deflection. All right, let's go back to, yeah, we are seeing some deflection, so we needed to put that there. Set the functions to, let's see here. It doesn't say what range we should be on. But I'd say we should tweak the A2R7 off adjustment. The A2R7 is this one right there. So let's adjust that. Too far, too far, too far, too far. It's very sensitive. Okay, let's short it and zero it and unshort it and zero it. All right, that looks good. I like that. Let's do it on negative. And negative goes off. So what should we do? Turn the function and rotate the DC0 fully to the left. There we go. Touchy adjustment. I'd say that's good. All right. Regulator adjust. Complete the amplifier balance. Short the volts to COM and ohms to COM. Short them all? Set function to plus DC. Meter should be zeroed within 2. Oh, this is complicated. I'm going to do this off camera. Okay, I got it all calibrated, and that worked out just fine. The way that you do it is you do a kind of a crude DC calibration for offsets and stuff, and then you go through the AC calibration part, where you put in a 400 hertz signal, a 1 kilohertz signal, and a 100 kilohertz signal. And there's adjustments inside for those things. And then you go to the ohms adjustment and adjust those on several ranges. And then you go back to the DC and you calibrate those for 3 different ranges. A lot of times the calibration is on one range, and then other ranges are just multiples of that are fixed in resistors, so you don't adjust them. You just adjust the lower one. So that's pretty typical. So I'll just show you here working in ohms mode. So I have it in battery powered right now. So when you turn it on, you can go to the battery and check, and the battery voltage should be above 15, which is the halfway mark. So as long as it's above halfway, you're good to go. So we're measuring about 20 volts, which is great. And the way that's done is the battery, when you click the switch, the battery is sent across 2 resistors to the meter. The meter is a 100 microamp meter, so that creates this 0 to 3 volt scale. And that's separate from all the rest of the meters, so the battery function always works no matter what the calibration has been set to. So we can go to ohms, and then we operate off of these 2 terminals. So I have my real high precision box here. It's 0.05%, so it should be good enough. So we're measuring 10, let's see, 100, so 0.1, 100, so it's 10 ohms, 20. So the way that you read voltage is on the upper scale. So you're either on a 3 scale or a 1 scale. The 3 scale is the lower scale, and the 1 scale is the upper scale. So 0 through 1 and 0 through 3.2. Those are the 2 scales. But when you're in ohms mode, you read the lower scale, which is a logarithmic scale. So we're here at 0.2 times 100. And so 3, 4, 5, 6, 7, 8, 9, 10, oops, and 0 is 10. So yeah, so everything seems to work just great. I love it that it's battery powered. I love that it's a 10 megohm input resistance. And it's because it's battery powered, it's floating. I can hook it up to any circuit and not impinge on it. And like I said, for a lot of things, having an analog meter is much better than a digital meter. A lot of times the digital meters are fluctuating, and you don't really know where it is. But when an analog meter is fluctuating, you can kind of guess its min-max, and you can kind of see where the median is just by looking at it. I don't know if I can simulate that here, but you know, if it was doing something like this, you'd say, oh, it's sort of 0.8, you know, that kind of thing. Whereas on a digital meter, the numbers be flickering around and you just can't read them. So it's great for audio type things. This one is especially good for audio type things because it'll give you dBMs into 600 volts. So dBMs are calibrated so that 0 dBm is 0.775 volts at 600 ohms impedance. And if you want to use a different impedance, there is a correction chart in the manual. See if I can find that quickly. Here it is. If you can see that. But this gives you whichever impedance you have and the meter correction. So 0 comes down to 600. Okay, so the zero will be at 600. And so let's say you're operating at 50 ohms, then this is 10, 20, 30, 40, 50 ohms. So the correction is like plus 10. So you can use this. But generally you're operating at high impedances in analog circuits. So maybe it's up here around 20K or something. But if you do put on a 600 ohm load on the output of something, then you can actually measure it in dBMs with a meter like this. I think 600 was a pretty typical standard for telephone. I'm not sure what else it was used for. I think some old audio equipment was 600 ohms, but yeah. So this is an HP427A voltmeter. The manuals are online, the service manuals online, schematics are online. Yeah, it's a cute little meter. I like it.